Ciao a tutti and welcome to this session. I'm Marco Obinu. I'm an Azure MVP based in Italy, working as an advisory engineer at SoftGem. Today, I'm glad to be here with you talking about one of my favorite topics, and I'll try to give you a quick overview of all the key aspects that you should look for while sizing an Azure virtual machine for a SQL Server workloads. Let's start with a basic concept. And in my career, I almost always faced with SQL Server systems that were licensed under a core-based licensing model. In these scenarios, if you want to maximize the return of investment in terms of licensing cost, you have to work with both an efficient application as well as a well-sized, well-configured virtual machine. If you fail in one of these areas, and you try to mitigate the issues by adding additional hardware to your system, you will probably increase the licensing cost immediately. Then, when you have to size a virtual machine in Azure for SQL Server workload, you have to face with some constraints that are not present when you do the same stuff in an on-premises environment. You have to deal with virtual machine families and sizes that determines several aspects of the virtual machine, like, for example, the CPU power. Different families are baked on different hardware, so you have to check the documentation to see what kind of CPU is behind them. And if you need a quick synthetic benchmark to compare the different families, you can look at the Azure Compute Unit values presented in the documentation for each family. Then, each family has its own CPU to RAM ratio. And if you are working with a production SQL Server workload, you will probably need at least 8 gigabytes of RAM for each core of your virtual machine. And then family and size also govern the storage aspects of the virtual machine. In this area, you should look for a virtual machine that offers you access to the premium storage like premium SSDs and ultra disks. Then you need a high uncached throughput. This is the channel the virtual machine uses to reach the durable disks that are hosted on Azure storage. And since this kind of storage has its own latency, you may need to increase the performance of your virtual machine by leveraging local storage on the virtualization host that currently handle the virtual machine. On this local storage, you can find the temporary disk of the virtual machine, as well as the blob cache that can be used in the SQL Server world to increase the read capabilities of your system. This storage is accessed by a channel that is named cached throughput in the documentation. So you need also high numbers also in this side. Then your workload will probably be subject to storage spikes during its running activity. If you want to handle this spike without having to size the virtual machine for them, you can try to leverage the virtual machine level disk bursting. This feature permits you to overcome the uncached throughput limits of the virtual machine for a short period of time, thanks to a credit-based mechanism. The last feature you should look for is the presence of the accelerated networking feature. This permits you to skip a virtualization layer in the networking stack of the virtual machine to obtain lower latency and a higher throughput. This is especially useful when you are working with high availability configurations that rely on data replications like for example, always on availability groups. Now, for a production environment, a mission critical environment, your best bet here is probably to use an ADS V5 virtual machine, because this kind of virtual machine can cover all the key aspects we have just talked about. Now, we've spent the right amount of time choosing the right virtual machine for us. we need now to define the correct storage subsystem that can support it. Otherwise, if we mess in this area, again, we risk to waste monies. We can choose between standard storage, premium storage, or ultra disks. Let's leave apart the mechanical disks that are not suitable for SQL Server workloads, and let's introduce standard SSDs. These disks, as you can see in the graph, have increasing performance depending on their size. Unfortunately, these performances are not so consistent during the time, and this relegates this kind of disk this makes suitable only for dev and test environments. If you need consistent performance over the time for a production workload, you should switch to premium SSD disk. With these disks, performance are provisioned. This means that you can obtain what you are paying for. And again, the size directly impact the performance of the disk, but here the numbers are way more higher than before. Like the virtual machine, both standard SSDs as well as premium SSDs support disk bursting. You can improve their performance to handle spikes for a short amount of time in a credit-based way, or in this case, also in an on-demand way that makes you pay a fee for overcoming the disk limits for a short while. Last but not least, if you need to address a workload that requires sub-millisecond latency, you should work with ultra disks. Here, things work in a different way. It's like if you have 3 different knobs, you can tune to obtain the desired volume size as well as its performance. And the bandwidth and the IOPS of the disk can be dynamically adjusted depending on your workloads. This permits you to reduce the performance of the disk and conversely its cost when the workload is not so aggressive on the storage side. Unfortunately, these cool features comes at a cost, and these disks are very expensive. They also do not support caching and might not be suitable for data files in the SQL Server world. Additionally, they currently don't support backup. This means that if you add one of these disks to your virtual machine, you won't be able to take a backup at the virtual machine level. You will have to rely on SQL Server backups to protect your data, but this may not be suitable in any scenario. Now, let's try to wrap up and put all things together. And you have to choose a virtual machine that can satisfy your requirements, and then you have to match its storage capabilities to a corresponding disk subsystem. Here, if you have to deal with large volumes, it's preferable to stripe multiple small disks instead of using a single large disk. For example, if you need a 2 terabyte volumes, it's better to combine a couple of P30 disks instead of using a single P40, because you can obtain the same volume size but with higher performance. And this strategy also permits you to leverage disk caching that is not available on larger disks. Then you should consider disk bursting to handle the spikes, as I was saying before, and you should also use your local temporary disk to host your SQL Server TempDB. This permits you to save additional Azure disks that you have to pay for to handle this database. Last but not least, you should always follow the well-known best practices for SQL Server storage configurations at the operating system level, like, for example, formatting the volumes with a well-known allocation unit size. If you want to know more about this topic, I strongly encourage you to have a look to official guidelines because they're very well written. Otherwise, you can follow my session at DataGrillen 2022, where I will cover these topics. And I think that a beer and a bratwurst can be like icing on the cake for these kind of arguments. In the meanwhile, thank you so much. Grazie for your attention. And if you have any question, feel free to drop me an email or a message on LinkedIn. I'll try to do my best to answer all of them. Let's keep in touch. Ciao.